All right, so today we're going to go ahead and go over our Unit 4 review that we did in class. Remember, this covers properties of operation, order of operations, expressions and equations, and prime factorization. So let's go ahead and get started with the first one. So I want to match each set of equivalent expressions with the property that makes it true. So let's start off with that first one. I have 3 plus 2 plus p equals p plus 3 plus 2. Well, what I'm noticing is that things are just getting moved around and really the changing of the order. So when we're changing order, right, we're talking about CO, change order. That's our commutative property. Remember, that means the numbers are changing order because if I were to replace this with the 1, we're going to get the same answer on both sides. So again, that's the commutative order. I have -3 plus 0 equals -3. Well, -3 is staying the same. So that means it's keeping its identity. That is the identity property. I'm looking at 7 on the outside of the parentheses. W minus 12 on the inside equals 7W minus 84. So again, I'm going to look there and I'm going to see that 7 is being multiplied by everything on the inside. And when that's happening, that means it's just multiplication. So I'm taking 7W, multiplying that, and I get 7W. 7 times 12 is 84. So this is the distributive property. I'm taking the outside number and I'm distributing it by everything that's on the inside. Next, I have 2 on the outside times 3 times 5 in the parentheses. And then I have 2 times 3, and then the 5 is on the outside. So what that is doing is it's associating different numbers together. So that's my associative property. It's changing or it's shifting those parentheses up or down. And then last but not least, I have the inverse. It's multiplying the 4 by its reciprocal. Remember, we learned that keep, change, flip actually means to multiply by the reciprocal. So that's our inverse. All right, let's go on to evaluating the expression. Remember, this just means to solve. We're just solving, and if I'm looking, I see more than one operation. Whoa, I see more than one operation happening. So that means we are doing GEMDAS. Okay, so I'm gonna look and I'm gonna see what my first step is. That's grouping. I look and 4 times -5, that is not grouping because they're not in one set of parentheses. It's -12 divided by 4, which if I do Dorito Man, negative, positive, it's a -3 plus, and I'm rewriting everything. I don't have any more grouping. I don't have exponents. I'm going to look for multiplication or division from left to right. I see multiplication, and again, I see that we're multiplying a negative. So I'm going to go ahead again, and I'm going to do positive, negative. It's a -20 plus -3. I'm now here and I see -20 plus -3. Well, I know that when I'm adding and they're the same signs, we're gonna add and keep the sign. So -20 plus -3 is -23. Next one, same thing, another GEMDAS problem. So I don't have any grouping. I do have exponents. And remember, in class, I said I want you to write it out because it's not -3 times 3, because then you would get -9 and your whole answer would be wrong. Take the couple of seconds it takes to write it out to show us -3 times -3 times -3. So now I'm going to go over it. -3 times -3. Well, I'm going to double check with Dorito Man. And that's a positive 9 times -3. Again, Dorito Man. And that's a -27. So that's a big difference between a -9 and a -27. So now I'm at 7 plus negative 27. I know that these are different signs, so I know it's 20 minus 7, or 27 minus 7, and that would get us 20. I know that 27 was larger, so that means there's more negatives, so it's a negative 20. Again, it's really important to remember that our exponents are showing us repeated multiplication. So negative 3 to the power of 3 is negative 3 times negative 3 times negative 3. Okay. Just as like 2 to the power of 2 is not necessarily 2 times 2, right? Or 2 to the power of 2, it's 2 times 2, right? You have to make sure you're paying attention to how we're wording that. Okay. Now we're going on to equivalent expressions. Remember, I'm going to show you since we already did our properties, and let's say I'm just not understanding properties or I don't really get the strategies. Okay, here's a new strategy. Remember, we talked about this. Everywhere we see a letter, we're going to replace it with a 2. So I'm replacing it with a 2. And don't forget to figure out what your magic number here is. We need to do 32 times 2 first. 2 times 2 is 4. 2 times 3 is 6. So I am looking for wherever I'm going to get 64. So if the answer is not 64, then that is not my answer. So 2 times 30 is 60. 60 plus 2 is 62. That's wrong. 2 times 30 is 60. 60 times 2 is 120. That's also wrong. And then 2 times 30 is 60. 60 plus 2 times 2 is 4. 60 plus 4 is 64. So this looks like this is going to be your answer, but let's just double check the last answer choice. Excuse me. 2 times 3 is 6, and 6 plus 2 is 8. So my answer is going to be C because it matched the 64 originally. Okay. Prime factorization. Remember I said I'm covering my prime numbers that are at the top, and we're going to have to remember some. So the basic ones that I would recommend are 2, 3, 5, 7, and 11. Those can get you started with prime factorization. Well, the strategy that we're using is the upside down ladder, or I'm sorry, the ladder method or upside down division. I can divide 180 by multiple prime numbers. It's however you feel, wherever you feel like starting off at. I'm going to start off at 2. We might have done something different in class. I know one homeroom, I think we did 5. Another homeroom, I think we started off with 2. So whichever one you start off with is fine, as long as it's prime and it works. So 180 divided by 2 is 90. And then I'm going to keep going. So let's do 90 divided by 3. That's a prime number. I would get 30. And then what prime number can I divide 30 by? Well, I'm going to go 3 again. And I would get 10. What prime number can I divide 10 by? And divide it by 5. And I would get 2. I stop because 2 is prime. So I'm done. So now we're going to listen in its exponential form, least to greatest, 2 to the power of 2 times, there's 2 3s, times 5. All right, next problem. Ooh, more PEMDAS. So again, I highly recommend we write it off to the side. And I'm going to ask myself, what's my first step? Well, grouping. Do I have grouping? I do. So I see 12 minus 4, which is 8. And we're going to go ahead and rewrite everything. Don't be lazy and make sure we're rewriting everything, because if we don't, that's when we make silly mistakes. I'm done with grouping. Do I have exponents? Why, yeah, I do. So I'm going to rewrite this to 2 times 2 times 2 times 2. So 4 of them. Not 2 times 4. It's not 8. I don't want to see 8. I want to see 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. And then 8 times 2 is 16. So it's not 8, it's 16. We're going to go ahead. We're going to rewrite so I don't make silly mistakes. I'm done with exponents. Do I see any multiplication or division? Remember, it's whatever I see from left to right. Well, I'm scanning, and I see 16 divided by 8. And I would get 2. Again, I'm going to rewrite. Okay. Oh, I'm not done with multiplication or division. I'm done with the division, but I'm going to keep looking and I see I still have some multiplication. So 8 times 4 is 32. Now I'm done with multiplication or division. And now I'm going to go from left to right with adding and subtracting. Remember, it's whatever we see first, not adding first all the time. So I see 10 minus 2, and 10 minus 2 is 8. So 8 plus 32, we get 40. So that is my answer. And I would recommend when we're doing order of operations, I would recommend you solve it twice. Because if you get a different answer the second time, then that means you went out of order of operations somewhere. All right, let's do the next GEMDAS. So again, I'm going to rewrite GEMDAS. Takes 2 seconds to do it. I'm going to ask myself, is there any grouping? And yes, I see 4 plus 9. 4 plus 9 is 13. Gonna rewrite it. And then again, I'm going to ask myself, I'm done with grouping. Are there exponents? Why, yes, there is. That's not 6 times 2. It's 6 times 6, which is 36. So 7 times 13 minus 5 times 36. I'm done with exponents. I do have multiplication. I see 7 times 13. So 13 times 7. 7 times 3 is 21. Carry the 2. 7 times 1 is 7, but I add 2, so that's 9. 91 minus, let's go ahead and do 36 times 5. 6 times 5 is 30. 5 times 3 is 15, but I add 3, so that's 18. So it's 180. Okay, I'm done with my multiplication and division. There was no division. Now I'm going from adding to subtracting or subtracting. I need to remind myself, remember when I make us hold up our finger and I'm like, can we take away 7 fingers from this? You're going to tell me no, right? So now I know that this is going to be a negative answer because that first number is a lot smaller than the second number. So I'm going to write a negative because I know it's negative. 180 minus 91. I'm going to borrow, make this a 17. 10. 10 minus 1 is 9. 17 minus 9 is 8. So it's a negative 89. Okay, which one is not, so this is a not question, an example of prime factorization and why? Well, remember, prime factorization is just like we did this one up here. I only want prime numbers. So I only want to see numbers that are divisible by 1 and itself. Okay, remember, just because it's odd does not mean it's prime. That's a silly mistake to make. So let's look. All of these numbers should be prime. 3 is prime. 5 is prime. 11 is prime. This is an example of prime factorization, so it can't be my answer. 7 is prime. 3 is prime. And 13 is prime. This is an example of prime factorization, so it's not my answer. Remember, I want not. 5 is prime. 7 is prime. C is not my answer because I want not. Let's see why D is the right answer, or which one is not prime factorization. 2 is prime. 9 is not prime. Just because it's odd doesn't mean it's prime. 9, I can divide it by 1, 3, and 9. So it has that extra factor in there that doesn't make it prime. So D is not an example of prime factorization because 9 is not prime. Okay, almost done. So now we're comparing equations and expressions. An expression, remember, has no equal sign. None of it. No equal sign. It's just like in math, it's an incomplete sentence. It's 2 plus 2. That's it. I'm not telling you an answer. An equation, right? Think it does have an equal sign. And we look for the keyword is, because that means I'm telling you 2 plus 2 is 4. So I'm giving you an actual explanation and I'm giving you an actual answer. So a number, doesn't matter a number plus 9. Is there an equal sign? No, that's an expression. 60 divided by 10 equals 6. That's an equation. It has the equal sign. 4 times n is, oh, not is 28. That is tells me it's an equal sign. So yes, this is an equation. X plus 6, there's no equal sign, so it's expression. 3x, that is an expression, no equal sign. A number could be any number. A squared, that's an expression, no equal sign. 6 more than a number, so 6 more than a number is 13. Has the word is in there, so this is an equation. Z divided by 3 equals 12. This is an equation. And then last but not least, a number could be any number minus 2. That's an expression. Okay, the model below represents the equation 4n plus 3 equals 2n plus 7. Which value of n makes the equation true? So if we remember, this is when I plug in each and every single answer choice into the model. So I'm going to plug in everywhere I see an n. I'm going to start off with A, which is 1. Okay, so 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. So here we get 4 plus 3 equals 7. So one side is 7. In order for 1 to be my answer, I should also get 7 on the other side. So 2, or 1 plus 1 is 2. So here I'm getting 2 plus 1, 2, 3, 4, 5, 6, 7. 2 plus 7 is 9. So this one can't be it because I didn't get 7 on the other side. A is wrong. Let's try 2. 2, 2. Where I see a letter, I'm going to replace it with the 2. 2 plus 2 is 4. 4 plus 2 is 6. And then 6 plus 2 is 8. So this is 8 plus 1, 2, 3. We get 11. In order for this to be my answer, I should get 11 on the other side. So 2 plus 2 is 4. 4 plus 7 is 11. So B is the correct answer because I'm getting the same answer on both sides. Remember, this is your review video and you following along, so watch this as many times as you need to. If you are really struggling with expressions and equations, rewatch this section, right? This is for you to go over. And if you still have any questions, please come reach out to me in the morning time.